Pamela, you're muted. You are muted.
See, when I produce, I unmute my cast for themselves.
That's good. How do you do that?
You use the
I can unmute you?
Yeah, you use the control room tools.
Oh, cool. Okay.
Yeah.
That's so thoughtful of you. You really are a much better host than I am.
I'm just a different host.
Just a different host. Well, hey, Pamela, how's it going?
It's going well. How's it going with you?
Good. You're back in your familiar surroundings, back from your Portuguese vacation?
It was not a vacation. I worked my ass off for a week.
Yeah. So did you get a chance to maybe watch some auroras?
No, I was annoyingly either in light pollution or fog or rain or all three simultaneously.
What about during that flight back? Did you take the Great Circle route? Could you look out the window?
I flew during daylight. Yeah. So the way they normally do it is when you fly to Europe, it's an overnight flight. And when you fly home from Europe, it's a daytime flight. And so I flew during daylight.
Yeah, we had a series, like two big sunspot flares blast towards the Earth, and they gave us like a series of solar storms across like Friday.
Now, did you get
Saturday,
to see it?
Sunday? No, I didn't either. So most of Canada got a great view of it, but the West Coast didn't really get much of a view. But last night, there was a huge meteor that flew across the sky in British Columbia, Washington, Oregon, and was visible in Northern California. Around 8:20 our time, and I was driving. It was 2 nights ago, and I was actually driving when it happened. So if it had been out my window, I would have totally seen it. But it just happened to go like over my head, and so I missed it. I've never felt so let down. I keep saying the universe owes me a comet. It delivered a great big meteor, but I couldn't see it.
That is so very, very sad. I'm sorry.
Yeah. It's your fault.
Everything's my fault. I totally take all blame.
Good. So if you've never seen this before, this thing we do, this is a live episode of Astronomy Cast. Today we're going to be doing episode 352, Water Everywhere. And we'll take about 30 minutes to record the show, and then when we're done, we'll stick around for a couple of minutes and answer some of your questions about space and astronomy. So what else? I want to say hi. If you want to post your questions, you can use the Q&A app, which I've enabled. And I'm going to say hi to Thomas Traniker, Helga Bjorkog, Michael Mayer, Will-Eyed One-E, Nancy Graziano, Guido Beaver. Man, it's the whole crew.
Yeah.
Douglas Crandall, Derek Tweedy, Rod Mole, Peter Waldman. So hey, everybody.
That's awesome.
Yeah. And if you have some questions as we proceed during the show, just go ahead and post your questions into our the Q&A app. And so theoretically, this should be the episode that goes out next Monday, and there should be an episode coming out today from last week.
Yeah, it's on the 365 feed. I need to poke at Preston, and if needs be, steal it from the 365 feed.
Is that the DragonCon one?
No, the one on 365 is they just stripped the audio out of our Hangout last week.
Yeah. Right.
So, okay.
Okay. No, we should have the good audio, though.
Yeah, no, I agree.
Okay. Okay. Right, let's get rolling. Are you ready to record?
I guess so.
We can wait.
No, I'm good. I'm good.
All right.
I'm wandering over to the software that requires me to press a red button, and it is recording in mono, as good software should.
So is mine. Okay, great. Here comes an intro. Astronomy Cast, episode 352, Water Everywhere. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Kane. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, a professor at Southern Illinois University, Edwardsville, and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing, Fraser?
Good. Have you got anything interesting to say about Cosmo Academy?
We have a bazillion classes going on, so sign up now. Please, please, please.
Yeah, I don't think I'll do the long version of this where I just listen everybody. Cosmo Academy is the greatest thing you could ever want, and you get to have these classes with amazing PhD researchers, and they'll teach you everything about black holes and observational astronomy, and it's the best. And it's a reasonable price, and you can learn from these brilliant minds. So if you haven't already, go sign up. Why wouldn't you? All right. Cosmoacademy.org?
Yes.
Okay. So wherever we find water on Earth, we find life. And so it makes sense to search throughout the solar system to find water. Well, here's the crazy thing. We're finding water just about everywhere in the solar system. So this changes our whole concept of the habitable zone. All right, Pamela, you put this one on the docket. What were you getting at?
Well, so it used to be like when we started this show, when people started talking about habitable zones and stuff, they were figuring, well, like that Goldilocks place where it's not too hot, it's not too cold, and you're able to support liquid water on the surface of the world. Well, we're now kind of finding liquid water everywhere in the solar system. And it's appearing more and more that what's actually required is something to prevent it sublimating away into the atmosphere, and a good case of gravitational squishing.
Right, which giant planets provide that in spades.
Yes.
Yeah.
And then we're also finding places with water that I know I never expected. It looks like the World Series, formerly known as a planet, now known as the largest asteroid, still getting called a planet by some.
It's a dwarf planet.
It's a dwarf. So Ceres, it's starting to look like, even though it's not exactly undergoing tidal heating from anything, it looks like it may have cryovolcanism, which means maybe it also, for some weird reason, has subsurface oceans. So it's getting to be a pretty watery solar system out there.
Right. So in the olden days, 7 years ago, well, older than that, astronomers figured the water was on Earth. The Earth is where the water is. That's that. Maybe Mars, but probably not. That's we can see that Mars has some ice caps. So maybe there's some water there.
Dry ice accounts for that quite nicely.
Yeah. But isn't there water? Couldn't they detect water mixed in that area? So anyway,
yes.
Yeah, and so that's it. And then, and then they know that there was icy moons around Saturn, and there's comets and all this kind of stuff. But it's all frozen snowballs. No water, no liquid water to be had. So what is our new understanding, and how are people sort of discovering this?
It's really kind of shocking. What we're now finding is Mercury doesn't have liquid water, but it does have water in the permanently shadowed regions in some of its polar craters. We are finding Venus is still a nasty, acidic, don't want to go there kind of place. We're not going to talk about it because really it doesn't have water.
Wait, but what about below the surface? I mean, there's more water on Earth below, there's mountains and mountains of water below the surface. Than we ever knew, that we're finding these pockets, but 10 kilometers down, mixed in with the rock. And so you get 10 kilometers down on Venus, it's a different place, right?
Well, and we don't know. I mean, the crazy thing about Venus is it's one of the weirdest surfaces in terms of not understanding its volcanic history. It looks like every large period of time that we don't really know, it pretty much has a massive outbreak of volcanoes the way a teenager might have an outbreak of acne. It just, the whole thing balloons up at once and resurfaces. Now the question is, in the process, is it outgassing all of the volatiles that are stored deeper down? What exactly is going on during this massive process? We don't really totally completely understand.
Right.
So Venus we're going to put into the other category of not really well understood in that category, but covered in really gross, nasty
we'll put it in the send more rovers category.
I'm not quite sure we're ready for rovers there, but balloons that circulate in the atmosphere.
No way. is it Jeffrey Landis came up with a Stirling engine that could keep a rover going on the surface of Venus for months. Awesome idea.
Not planned to be built by anyone at the moment,
Yeah,
though.
but in my mind, in my mind, I'm
Okay.
speculating.
Okay. So
Please
so
continue.
yes. So Earth, we kind of know we're kind of covered in water. The near-Earth asteroids that we're generally contending with, they rotate. They generally don't have ices on them. You occasionally see evidence of volatiles have escaped. In the case of those that are really dead comets more than they're plain old rocky asteroids. But for the most part, near-Earth asteroids in the inner part of the asteroid belt is a dry place. This is because the sun baked everything dry. I kind of bypassed Mars in there. Mars, liquid water that's extremely salty is what it appears. So it has briny water that is able to stay liquid at significantly lower temperatures than non-salt water can.
That's good
Um,
enough for life.
that's we sure have salt water here on Earth that supports life,
Ah,
and so this salt water is a bit saltier, more think Dead Sea than Atlantic, but uh, there's potential there. So Mars has, it appears, subsurface water in the form of briny water. Then moving outwards, as we move out through the asteroid belts, go past Vesta, past the what we call the water line, the snow line in our solar system. This is that point in the solar system where the distance that you are away from the sun is such that things that formed during the early solar nebula formed with water and didn't get baked to the point of not having water anymore. This is part of why we wanted to send the Dawn spacecraft to both Vesta and Ceres, as they formed on either side of this line, we think. Well, now it's appearing that as we've been observing Ceres in the ramp up to getting the Dawn mission there, it's kind of looking like it may have cryovolcanism, which indicates water. That one's kind of confusing. Then as we move out, we have Jupiter next. We already knew Europa, subsurface water, ice on the surface. It's kind of water in different phase states.
but it's not the only one. I mean, that's the.
It's not. No, it's looking like Ganymede has water, Callista has water, Io is another kind of baked kind of place.
Yeah.
Lots of nasty volcanism. Kind of awesome, but not really a watery kind of world. But then as we move out towards Saturn, we find the tiny worlds like Enceladus actually appear to also have these subsurface oceans as well. And so it's kind of like subsurface oceans everywhere. And there's the question of now, what are we going to find when we get to Pluto?
Pluto, right.
So Pluto and Charon are certainly close enough that perhaps, maybe, sort of, you could end up with some sort of tidal heating. Don't know, probably not. But wow, what if?
Mm-hmm.
So yeah, the solar system is turning out to be much more watery than previously thought.
So, of all of those places, which one is the best candidate? Which is the best place for us to look, do you think?
The one that I didn't name, Titan. So Titan, you actually have massive organics already in place. This is a world that has methane and ethane at the transition point where they can go from vapor to liquid to solid. And with that triple point in play, you end up with a whole weather system. You end up with lakes that, depending on where they are either methane or ethane. Majority, it's looking like they're majority methane. But there is also water in this crazy environment. And so you have all the organics. You have a complex water cycle, or liquid cycle rather. You do have water. So that's an excellent starting point. And as has been noticed before, its atmosphere is actually out of chemical equilibrium for what you would expect for a system that doesn't have life at that particular distance from the sun. So there's already this weird, okay, there's either chemistry we don't understand or there's life.
But it would be underground. That the surface of Titan is cold enough to freeze methane and have some methane snow. So you got a ammonia ocean. So you need to go underground, under the surface, and that's where you could have these reserves of liquid water.
Well, and you can also have, perhaps, we don't know, life that lives in the methane and ethane.
Yeah, that's a whole other kind of life.
Yeah, and we know our planet Earth had methanogens in the past, so the idea of a more methane-oriented life form isn't even alien to our own world.
Whoa. And so then there's this idea of panspermia, right? We did a whole show on this idea that life is moving around the solar system. And we know this for sure. We found meteorites from even Vesta, right, and Ceres, and from Mars and the Moon, and we find these in Antarctica. We pick them up off the ice, and something's been traveling around in the solar system for 3 billion years since it was blasted off. And this idea that every part of this journey, life can survive it. It can survive being blasted off the world. It can survive being in space for a few million years. It can survive re-entry, and theoretically. And so you could imagine, right? You took a meteorite, it made the journey to Europa, somehow got into that ocean underneath where it's probably going to be rich in organics, heat sources. It could be happy.
Well, and it could also be a death plague. And that's the weird thing to think about, and it's why we keep sending spacecraft into the atmospheres of first Jupiter, and now we're going to do it to Cassini in 4 years with Saturn. There's the concern that life may be able to form through cold processes in clays, in ices, and there's been some really interesting experiments. There was a radio lab on this a while back. And it could be that life independently arose in more than one place. And if we send a rock from here to Europa, or a spacecraft, or an undersea probe, that it could have the same sort of devastating impact that, well, Europeans had on the New World when they came here. Different biologicals carry different bacterias with different immunities. And this is a serious concern. So, yeah, there could be life everywhere, and then we could successfully kill it. One of my favorite...
Replace it. with our locally grown bacteria.
Replacing involves killing.
We're terraforming these worlds.
We're killing.
Mm-hmm.
But
you can't terraform without killing everything that's there already.
My favorite scientific American capture of all time, I've brought it up before, is one where it discusses the impact that killed the dinosaurs, created a shockwave that flung dirt, plants, and dinosaurs at escape velocity.
The impact that terraformed the dinosaurs.
And flung them to other worlds.
And flung dinosaurs to other worlds. Yeah. You just imagine some dinosaur just entering the Martian atmosphere and just landing on the surface. Wasn't that an episode of South Park?
It sounds like
There's a killer whale on the surface of the moon. Anyway.
So that's how the whale got there in Hitchhiker's Guide.
Yeah. No, that's a different story. That the whale was part of the infinite improbability drive and was essentially creating, because it was a very unusual thing. But I see what you're saying. I see what you did there. So we've got this idea that there's water everywhere. So how on Earth or in space are we going to be able to study this? I mean, we've got this situation where this water is below 10 kilometers of ice. You've got cryovolcanism. You've got Enceladus. That's tough. So
with Enceladus, it's polite enough with the cryovolcanism to fling ice water, ice, which is a phase state of water, up into the lack of air where spacecraft can fly through this. And that's actually one of the planned orbital passages of the Cassini mission during its final 4-year phase. They are going to fly through where the geysers give off all of their particles, and they have on board instruments that are actually capable of capturing the particles and measuring what they're made of. So hopefully there'll be some nice big ice crystals that are captured, and we can look at the salts, we can look at what other materials are in the water, look at all of the impurities, confirm that it is H2O and not something else. It's one of those awesome things when space flings things up into reach of spacecraft.
Perfect. And we've got something a little similar happening. I guess that's going to happen with Ceres. Something's a little similar with what's happening on Europa, that there's plate tectonics, ice plate tectonics on the surface of Europa. So you get the situation where the plates are going to crack open, or they're going to be sliding over top of each other, and potentially material is going to be at the edges of these, at the subduction zones. You're going to have material from deep underneath being brought to the surface.
And it's weird trying to understand exactly how Europa's surface works. And Enceladus is, because it's a different mass, even weirder physics in some ways. You have the tiger stripes on Enceladus, which appear to be where the water's escaping. And then with Europa, we actually can see all of the organic materials that get sprayed down as the water particulates come back down along the cracks. And with Europa, it's this mix of tidal tectonics and weird hydraulic effects that we're only learning to understand by studying how glaciers are interacting with the seas.
Yeah, it's like the plate tectonics on Earth, but as you said, it's hydrodynamic forces, not rock, which has different physics. But then Titan, like, how on Earth would you get at the stuff on Titan? Or as you said before, right? Like, what if there is underwater reservoirs on Venus? I mean, that's just forget it.
Sampling materials with Titan is another case if you just need a spacecraft to pass through one of the ash plumes. We've actually been able to see those in silhouette. That's less of a stress. It's when we actually want to get deeper samples that it starts to become problematic.
We need that sailboat on Titan.
Well, yeah, that would work. I heard this great description. Titan's surface is such that you could pretty much send anything you wanted, and ideally you'd want something that can go back and forth from swimming to flying to roving. And you have the winds, you have the lakes, you have the, we think, mostly solid surface. And so you're in this amazing situation where any spacecraft goes.
Well, you could fly on Titan. If you had wings,
yes.
You could fly around on Titan just with your arm strength, because the gravity is so low, and yet the density of the atmosphere is so high. It's like twice as dense as the atmosphere on Earth. Like, you don't realize that there's this moon that has this dense of an atmosphere that you could work. Of course, it's cold enough to freeze methane, but don't let that worry about it.
And the reason it's able to retain this atmosphere is because of that cold. The atmospheric particles are moving so slowly that they're not randomly colliding and hitting escape velocity with their rebound velocities. So Mars is just enough warmer that it struggles a lot more to keep its atmosphere.
Yeah. So I guess it sounds to me like you're saying, and tell me if I'm wrong, you think we should send spacecraft everywhere.
Well, yeah. Why not? I mean, it's an awesome solar system out there. Every world needs its own spacecraft. We should have HiRISE cloned and sent to orbit moons.
Curiosities on every place with solid surface.
Yeah. And unfortunately, the one frustration is we're kind of out of our nuclear sources for power. And Curiosity, it's going strong, but what do we do further out? And we can't go back to Spirit and Opportunity's usage of solar panels, because as you get that far away from the sun, you just don't get a high enough density per square centimeter flux, basically.
Yeah. By definition, you're out in the cold.
Yes.
And you need a nuclear reactor. I'm sure that someone will think of something. I'm sure
Well,
someone's going to
yeah,
bring some program back online.
you say that, and that then Congress gets involved. The problem is the word radiation is involved and radioactive, and you
They don't
have
mind
to.
building bombs.
They don't mind building bombs, but they've actually even largely gotten out of that business. So the question is, how do we turn on a facility to create all of the isotopes that are needed for these radiothermal generators?
Well, the Chinese will do it then.
Yes, that's probably true.
There you go. Problem solved. Um, all right. So, but then there are some missions in the works right now, and there's some stuff that's heading out right now. So, are there any missions that are even gonna get anywhere near trying to help us understand if to follow this trail and continue on this investigation?
We are looking at some European missions, JUICE in particular. Um, Basically, we're going back to Jupiter. And as we look more and more at Jupiter, as they plan out these missions, you always have to worry about losing your pet instrument, losing your pet probe. But I think that JUICE may be where our best new hope is at
So,
in
what's
terms of.
juice? If people
I
haven't heard of juice, because we haven't talked about it much in this.
Well, it's the normal missions are dead to me until they actually launch. Um, but JUICE is a European mission that is going to go to the Jupiter system, and I have to admit that's pretty much all I know right now, other than
Jupiter
people are
icy,
exciting.
icy.
I shall Google
Yeah, I forget what
the
juice stands for.
audience.
Yeah. Well, but it's crazy because we don't have anything at Jupiter right now.
No. So when you Google JUICE, you get a very cartoonish diagram. It's a European Space Agency mission,
Yeah.
and it does have a Ganymede lander planned,
Cool.
and so it will do an interplanetary transfer, Earth to Venus, Earth Earth, so lots and lots of orbiting. It will use Ganymede and Callista for gravitational braking. Um, Variety of different orbiters, but landing on Ganymede's kind of the coolest part. It will do 2
Right.
flybys of Europa and then linger at Ganymede and Callisto.
And there was so Juno was launched in 2011, and that's going to get there in 2016. But I don't think it's going to have the ability to study the moons.
It
No.
doesn't have the budget for it.
No.
But JUICE is our next big
Okay,
hope
cool.
for moon exploration.
Yeah. Cool. And then does this like tell us anything maybe about other worlds, other star systems? Because this we're at this point, and of course, wouldn't it be great if there's such a thing called the terrestrial planet finder that would be able to look at the atmospheres of other worlds? But you see some of the characteristics like water in the atmosphere, water vapor in the atmosphere of another world. That's another candidate for life.
And the thing that has me really excited is we're at this point where if we find life even at its lamest single-celled possibility somewhere else here in the solar system, that has originated somewhere else in the solar system, that starts to give us a sense of how easy it is for life to come into existence. And we're now finding the diversity of locations that life could exist is so much more than that Goldilocks band.
Yeah.
So the possibility that we're alone goes down every new time we find a habitable environment. But the other side of that is if we start exploring these liquid environments and we never find life anywhere else, then maybe we do need to slow down and start thinking that maybe it is harder to get life than we'd hoped. So we're at
Oh,
the point of being able to start getting better numbers for that great Dirac equation. Sorry, not Dirac. That great
the Drake
Drake
equation.
equation. The great Drake equation of how probable is life?
Yeah. All right, cool. Well, thanks, Pamela.
Thank you.
All right, let's save.
Yep.
Hold, please. Someone asked about Sylvan Westby asked about the has the DragonCon episode made its way to us yet?
No, let me drop Rain another email, and I'll also ping her on Facebook.
Yeah, because that's such a good one. Sorry, just give us 1 second. Just exporting.
And I am literally emailing Rain and messaging her on Facebook.
Yeah.
And sneezing. We're at that time of year where you keep hoping everything will just stop producing pollen, and it doesn't want to.
There is no real distinction between what allergy season is anymore, is there?
This year, we get this span of time in August when everything dies, and I'm good with that. And then they have nice dry corn to harvest, but this year nothing's dried out, and the corn is bigger than I've ever seen it, and there's still corn smut in the air. And yesterday I got thoroughly made fun of for saying I can't wait for all the corn to be gone, and it was like, it's just going to come back next year. Yeah, I live in the land of corn.
Okay, so here we go. Get ready.
Okay.
Are you ready? Ready for questions? Next-gen rover that can carry detachable, terrestrial, submersible, or atmospheric packages depending on the target environment. This is a conversation we've had a bunch of times, which is that they need to settle on a space-based platform and a ground-based platform, and then trick them out with the different capabilities that are required for the mission, and get really good at building curiosities. 10 curiosities.
And this goes back to the way a lot of the early probes were. Even Cassini, to a certain degree, was built on the same platform as Voyager 1 and Voyager 2 were. For a long time, we were building off of a set platform that had swappable stuff and things, but it was proven technology that they just kept upgrading and upgrading. But we really have gone very much into the let's reinvent the wheel.
Yeah, and it really is. Let's reinvent the wheel. You look at what Rosetta looks at, and look how different it looks from Mars Express, and how different that looks from Epoxy, and how that looks different from Juno. And like each one is literally from the ground up.
Well, not entirely. To be fair, they do often use the backup instruments from one mission for a new mission. So Lunar Reconnaissance Orbiter, for instance, has cameras identical to one of the Mars missions.
Right. And I mean, you can see that does make a certain amount of sense, that for the mission you're going to want to have the structure. Like if it's Kepler, it's going to need to have a big mirror, a primary mirror, and it's going to be very different if it's going to be a gamma ray telescope, and it's going to be very different if it's going to be so there is a certain amount of that, but I don't know, it still just feels like it's not as efficient as it could be. And I would be, if I were running the show, I'd be having an assembly line. Did you hear, this is totally off topic, but did you hear that Elon Musk said that they're not taking SpaceX public? And
no, that's kind of awesome, actually.
Right, and he said the reason we're not taking SpaceX public is because SpaceX's job is to create a city on Mars. And if their shareholders get involved, they're going to want to make money as opposed to build a city on Mars. And so SpaceX will never be a public company.
That is all kinds of
Isn't
awesome.
that just so great? You're just like, yeah, now that's commitment. Like, because he's turning down, because like, what that means to him as the CEO and big shareholder is he's turning down billions and billions of dollars. But he knows that if it becomes a public company, it will not be the place. It will no longer try to get people to Mars. It's amazing.
There, there's a difference between the things that you have to do to create the best possible product and the things that you have to do to create the most profitable product. And I hate it, but too often quality and advancement fall prey to we need to build the cheapest thing that earns the highest profit.
Yeah, yeah. I just thought that was wonderful,
Yeah,
and just
yeah,
like
I
what a
agree
great thing to say.
completely.
Roshan Bakari asks, can water in the moons of Jupiter or Saturn be different colors because of microbial life?
Yes. It can also be different colors based on what minerals are in it. If you think about it, the processes that end up creating different colored liquids at Yellowstone, there's no reason that those exact same mineral and bacterial the processes couldn't also happen anywhere else in the
Yeah,
solar system.
is it Rio Tinto? There's this red river in Spain that's
Yes.
a lot of it is you know.
That one's a little more algae driven, but
Yeah,
in
yeah,
terms of the springs, the hot springs, volcanic springs that they have at Yellowstone, a lot of that is strangely colored due to mineral processes rather than
yeah.
due to algae processes.
Guido Bieber asks, Ganymede lander on Ganymede and Titan? Yes, sir. So, um, agreed. A lander on Ganymede would be awesome. So let's hope the Juice mission pulls it off. Michael Jobin notes that we need better solar cells. Yes,
Getting there.
getting there, but
It
good
doesn't
solar
help in
cells
the
aren't
outer
going to
solar
help. Yeah,
system.
at Pluto, no, you need to go nuclear.
And also the weight to energy ratio is still not there. And if you want to be highly maneuverable, you don't want giant solar panels.
Thomas Tranneker says, and we actually didn't get into this, which is, are the water molecules forming in the nebula, or do they form somewhere else? Where did all that water come from?
It appears that they probably were part of the solar nebula.
Yeah. Okay. Tom Nathy asks, any thoughts on Rosetta's Site J selection? What might they find? Any water, organics, minerals?
So this is, I think, a result that came out in the past few hours. I know today they're announcing the
The landing spot.
primary and secondary landing sites for the Philae lander that's currently riding piggyback on Rosetta. I have to admit, other than knowing that there's 3 potential landing sites on the body and 2 on the head of the great duck, I don't know which are primary and secondary yet. This is breaking news, and
Yeah.
I wasn't.
You were recording a show.
I was.
Yeah, me too. I'm sure we'll cover it in the weekly Space Hangout. Hannes Raiden asks, could a planet have surface water like Earth even outside the habitable zone? No, because that's by definition what the habitable zone is.
So there's a few short-lived caveats on that one. One of the reasons that the Earth is so warm is because we have a lot of radioactive decay going on deep within the planet. This generates heat. Heat is given off. We end up giving off more heat than makes sense if it was only due to solar heating. So you could nominally have surface water that was either heated from below via geothermal events or was heated because the whole planet was very hot due to radiation, but it would require it being large enough that it wouldn't sublimate. That's the problem on Mars, is liquid water sublimates pretty much instantly.
Mm-hmm. So that's sort of the definition, which is that for you to get liquid, the habitable zone is the place within the solar system where you could get liquid water on the surface of the planet. And obviously Venus, in the habitable zone,
A
no
little
liquid
overshot.
water. Mars, in the habitable zone, no liquid water. So it's a rough guide. It's not
Well, and
specific.
I really think we just need to toss the whole idea out the window because tidal heating is so much more important than we'd really given thought to.
Um, Will-eyed Oni says we need to be sending out probes like the Empire looking for the rebel base. Agreed. That's what
Yes.
you want. You want
Yes.
probes, little probes that are just going out one after the other, so many different destinations. We don't talk about the big spacecraft. We talk about the fact that there's 40 probes orbiting Mars. They don't even have names. They're all over the place. They're landing, they're probing, they're prodding, they're exploring, they're swimming, they're
There's
everywhere.
a great plan that, as near as I can tell, is not being built by anybody that was presented at the Rome European Planetary Sciences Conference, I think in 2010 or 2011, I don't remember which. The plan was to essentially throw lawn darts at Venus, and they buried themselves except for their little radio antenna. And they had a splayed out solar array, and I heard someone else say similar for wanting to do that on Mars, and the idea of sending out these lawn darts that would study weather and seismographic events. That was awesome.
Uh, Challenge. What is the smallest feasible spacecraft that you could just send to Mars that could communicate back with Earth? Like I think that would be interesting to see what that would look like. Some tiny little spacecraft that
Yeah.
has enough of a transmitter to be able to communicate from Mars back to Earth.
The real issue, I think, becomes how much fuel do you need?
Yeah, no, I mean I mean you will need some, but you'll probably need a lot less than something bigger. The point being that could you then get, you can imagine fairly small probes. In fact, you just need small probes that then orbit Mars, and then they communicate to some communications array like Mars Express or something that could
Right.
then get the communications back to Earth, and then you don't need a very big spacecraft at all. So I think, I don't know, it feels like in this era of miniaturization, with what we're seeing with the microsats, the nanosats, the things are starting to get built, the picosats, and launched for pennies on the dollar.
Yes.
You could start to see some of those technologies get sent to some of these other planets. Like,
I just want to send lawn darts that have radio transmitters and solar panels to
yeah,
Mars to look at seismographic events. I mean, one of the things we're pretty sure it's a tectonically dead world,
but is it?
and we've done a certain amount, but it would be cool to have that full planet weather
Yeah.
grid and just looking to see what sorts of tectonics do you get with the evaporation of, or sublimation rather, of the poles? What
Totally.
there's active dunes. Imagine if we had a good GPS system around Mars and we could measure how the dunes are moving. The same is true on Titan, where it also has active dunes, and
Yep.
we need weather systems.
Michael Meyer asks, could there be a gas giant closer to its star than Jupiter with moons with surface water?
Yes,
Yes. Okay.
Endor could exist.
Totally could exist. In fact, it would get a double warming because it would be in the habitable zone, but also it would probably have the tidal flexing from its planet. So you might get the tidal flexing keeps the bottom of the ocean warm, but the rays from the sun keep the top, and it keeps it in balance. So I think you could totally get that. Tom Treleski says, life may be nice, but can we use the water to create fuels for our space travels? Helium or hydrogen and oxygen, useful elements. Absolutely.
Yeah.
Yeah. And this is what Mercury would be great for. This is what the moon might be great for, is if you can find these deposits of ice, you land your spacecraft.
So I think the word great is a little bit of an overestimation because it's still going to be a bear to extricate all of the water from the minerals. So it's more a matter of could you? Why, yes. Is it easy or efficient? No, not so much.
You get like some short period comet and you just move it into a nice orbit that's Earth trailing. And so it's just following the Earth and you just refuel there.
There's a book called, I think, Leviathan or Leviathan Wakes that talks about future asteroid colonies mining their ice from the outer icy bodies and bringing it in.
And Michael Myers is noting, he says, I saw things. So, like, how cool is that? Death Valley, salt pool, little critters swimming in the water.
Yeah, it's kind of amazing. Life likes to live everywhere.
Yeah. Life will find a way. Um,
And there is actually a new form of life found deep in the oceans, these little mushroom-like critters, and they can't figure out where to put them in the tree of life.
Aw. All right. Well, I think those are the questions that I wanted to pull out of this. So
Okay.
thanks, everybody who participated. Really appreciate it. And we will see you all next week. We'll see you next week, Pamela. Anything to
That's
announce? Anything
great.
to mention?
No, maybe next week. Right now, it's simply returning from travel and trying to get everything under control.
Cosmo Academy. Go to
Oh, I'm
cosmoacademy.org.
I'm going to be in Australia in 2 weeks. Uh, Follow
Really?
my Twitter feed. I'm going to be announcing you can get tickets to come see. I'm going to be at the Siding Springs Observatory's
Right
Eye
on.
Telescope dedication. And then I'm giving a series of different presentations in Melbourne, including at Swinburne University and a variety of other places. There's going to be teacher PD events.
Is iTelescope's going to have a computer-based telescope located at Siding Springs?
Yep.
Nice. That we could maybe tap into and observe the night sky from the southern hemisphere
During our daylight, even.
during our daylight. I'm liking this idea. Say hi to everyone there for me.
I will. I will.
Awesome. All right. Well, thanks everyone for watching. Thank you very much, Pamela. Where can people find out more about Dr. Pamela Gay?
You can find me at cosmoquest.org, and you can find my more personal rantings at starstrider.com.
And are you on the Twitters?
I am. I am, in fact, at Starstrider with a Y because I wasn't thinking when I was in my early 20s.
I'm at FCain. It's very easy. FCAIN on the Twitters. And yeah, and then all the other places, the Universe Today's, and of course the work I'm doing over on HeroX. All right, well, thanks, Pamela. It's great to see you. Thanks, everyone, for watching. We'll see you all next week.
Bye-bye, everyone.
Yeah, we had a series, like two big sunspot flares blast towards the Earth, and they gave us like a series of solar storms across like Friday,
Now, did you get to see
Saturday,
it?
Sunday. No, I didn't either. So most of Canada got a great view of it, but the West Coast didn't really get much of a view. But last night there was a huge meteor that flew across the sky in British Columbia, Washington, Oregon, and was visible in Northern California, around
Dang.
8:20 our time. And I was driving. It was 2 nights ago, and I was actually driving when it happened. So if it had been out my window, I would have totally seen it. But it just happened to go like over my head, and so I missed it. I, I've I've never felt so let down. I keep saying the universe owes me a comet. It delivered a great big meteor, but I couldn't see it.
That is so very, very
Yeah.
sad. I'm sorry.
Yeah. It's your fault.
Everything's my fault. I totally
All
take all
right.
blame.
Good. So if you've never seen this before, this thing we do, this is a live episode of Astronomy Cast. Today we're going to be doing episode 3 and observational astronomy, and it's the best. And it's a reasonable price, and you can learn from these brilliant minds. So if you haven't already, go sign up. Why wouldn't you? All right. cosmoacademy.org?
Yes.
Okay. So wherever we find water on Earth, we find life. And so it makes sense to search throughout the solar system to find water. Well, here's the crazy thing. We're finding water just about everywhere in the solar system. So this changes our whole concept of the habitable zone. All right, Pamela, you put this one on the docket. What were you getting at?
Well, so it used to be like when we started this show, When people started talking about habitable zones and stuff, they were figuring, well, like that Goldilocks place where it's not too hot, it's not too cold, and you're able to support liquid water on the surface of the world. Well, we're now kind of finding liquid water everywhere in the solar system. Um, and it's appearing more and more that what's actually required is something to prevent it sublimating away into the atmosphere, and a good case of gravitational squeeze.
352, water everywhere. And we'll take about 30 minutes to record the show, and then when we're done, we'll stick around for a couple of minutes and answer some of your questions about space and astronomy. So, what else? I want to say hi. If you want to post your questions, you can use the Q&A app, which I've enabled. And I'm going to say hi to Thomas Traniker, Helga Bjorkog, Michael Mayer, Will-Eyed One-E, Nancy Graziano, Guido Beaver. Man, it's the whole crew.
Yeah.
Douglas Crandall, Derek Tweedy, Rod Mole, Peter Waldman. So hey, everybody.
That's awesome.
Yeah. And so yeah, if you have some questions as we proceed during the show, just go ahead and post your questions into our the Q&A app. And so theoretically, this should be the episode that goes out next Monday, and there should be an episode coming out today from last week.
Yeah, it's on the 365 feed. I need to poke at Preston, and if needs be, steal it from the 365 feed.
Is that the DragonCon one?
No, the one on 365 is they just stripped the audio out of our Hangout last week.
Yeah. Right.
So, okay.
Okay. No, but we should have the good audio, though.
Yeah, no, I agree.
Okay. Okay. All right, let's get rolling. Are you ready? Pamela, you're muted. You are muted.
See, when I produce, I unmute my cast for themselves.
That's good. How do you do that?
You use the...
I can unmute you?
Yeah, you use the control room tools.
Oh, cool. Okay.
Yeah.
That's so thoughtful of you. You really are a much better host than I am.
I'm just a different host.
Just a different host. Well, hey, Pamela, how's it going?
It's going well. How's it going with you?
Good. You're back in your familiar surroundings, back from your Portuguese vacation.
It was not a vacation. I worked my ass off for a week.
Yeah. So did you get a chance to maybe watch some auroras?
No, I was annoyingly either in light pollution or fog or rain or all three simultaneously.
What about during that flight back? Did you take the Great Circle route? Could you look out the window?
I flew during daylight. Yeah. So the way they normally do it is when you fly to Europe, it's an overnight flight. And when you fly home from Europe, it's a daytime flight. And so I flew during daylight.
Ready to record?
I guess so.
We can wait.
No, I'm good. I'm good.
All right.
I'm wandering over to the software that requires me to press a red button, and it is recording in mono, as good software should.
So is mine. Okay, great. Here comes an intro. Astronomy Cast, episode 352, Water Everywhere. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Kane. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, a professor at Southern Illinois University, Edwardsville, the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing, Fraser?
Good. Have you got anything interesting to say about Cosmo Academy?
We have a bazillion classes going on, so sign up now, please, please, please.
Yeah, I don't think I'll do the long version of this where I just listen, everybody. Cosmo Academy is the greatest thing you could ever want, and you get to have these classes with amazing PhD researchers, and they'll teach you everything about black holes.